let us talk to you about our small-scale high-tech equipment for the Global Artisan C-Sink. So maybe, Mohammed, you can jump to the next page. I'll give you a quick intro what we started with as a company and why we have went the direction we went. Mohammed, you can jump to the next page. Okay, perfect. So we started 2 years ago as a company. We wanted to be a biochar projects developer under the Global Artisan C-Sink because we're based in Southeast Asia, but we didn't want to work on the TLAT or Contiki equipment, but we wanted to go something high tech. Then we realized that, Mohammed, still you can go back. Then we realized that there is no available high-tech, affordable high-tech equipment. Mohammed, could you go back, please?
This one?
No, the second page. Yes. So we realized there's no good high-tech, affordable equipment in the market. So we decided to develop our own. So, Mohammed, can you go back? To the second page, please. Sorry, everyone.
Because this is what I see in my screen.
Okay, let's stay there.
One forward.
So just to share with everyone, I know everyone knows about biochar. So let us just, I'll not go into biochar, let's just go into like a Global Artisan C-Sink. So just to give you a quick intro, some of you might not know that much about it. It's one of the standards under Carbon Standards International, which is focused on small-scale production. I still want Mohammed's second page. I don't know why you're jumping to the third page. I would like second page, please.
I think you have a time lag between Mohammed and
Okay.
Pavel.
Yeah, because in my page it's like the wait, guys.
Okay, I will just continue assuming there is second page. I'm sorry, everyone. There is a poor connection in Manila, so we are still on the second page. So Global Artisan C-Sink is for the carbon credit certification in the developing countries. It was developed to enable certification of the biochar production and application in developing countries, allow smallholders to benefit from carbon credits, and allow project developers to develop centralized project in a cost-efficient way. But it came with like multiple challenges because there were TLAT and Contiki used primarily. It's a tedious and labor-intensive process, lots of CH4 emissions, small production capacity, a short useful life of these equipment, often just a couple of months, MRV challenges that have been tackled by a couple of providers in the market, but it's still imperfect because it requires people to input the data. And obviously financial resources, limited financial resources and financing options. So great idea to develop biochar production application in the developing world, but number of challenges to scale it up. So what we decided to do, and then I will hand it over to Mohammed, but we basically decided to develop a high-tech, still small scale, but much larger scale capacity than typical Contiki, automated, low emissions, close to no emissions, with a good processing capacity and performance profile, as well as still affordable. So that's what we developed. And Mohammed, maybe you want to start with this page and then go into more details to give everyone an introduction how our equipment works.
Yeah, sure. Thank you, Paul. Sorry, everyone, for the trouble with the slides because actually it's moving here, but I'm not sure if the slide is not moving. As Powell shared already, so our equipment is actually a small scale, semi-automated carbonizer to produce biochar. As you can see in the slide, the dimension of the equipment is quite small and the weight is up to 600 kg. And actually for the processing capacity, we can use two types of feedstock. The first one is unpelletized feedstock, and the second type of feedstock is pelletized feedstock. using this different type of feedstock, we can process different processing capacity. Of course, with the pelletized feedstock, we could process much higher feedstock per hour. And the biochar yield, it's in average, we can get biomass to biochar conversion up to 40%. And the use of fuel to feedstock ratio within range of 15 to 20%. And also, it's important to note that in order to be able to produce like proper biochar quality and also the process, we need to dry the feedstock below 20%. Best will be below 15%. And since we are using a microcontroller based system, it allows us to allows the operator to be minimal intervention, which is we need only 2 to 4 hours per day manpower. Mainly the operator involved in feedstock preparation, loading the feedstock into the hopper, and also collect the biochar from the collection bin. Now let me present to you a bit more detail on our product or equipment specification. In the right side, you can see like the drawing or the picture of our whole equipment. There are some main parts there. We have 2 hoppers. The bigger one, it's a feedstock hopper where the operator load the feedstock. And the smaller one is the burners hopper where the operator load the fuel for the burner. And the cylinder one, it's the pyrolysis and combustion chamber, where inside this combustion chamber, we have a spirited chamber between pyrolysis and combustion chamber. It's spirited, so it allows the feedstock to be heated indirectly, meaning we are able to produce higher quality of biochar because less oxygen involved in the process. And at the same time, the pyrogas or the syngas produced during the pyrolysis are used as a fuel for the burner. So that's the overall parts of the equipment and also the general process of how our equipment works. But I will talk a bit more detail later in the other slide. For the product highlights, actually, we have some key highlights. The number one is that we use mostly stainless steel 304 for our equipment. Why we use this? Because the main reason is because this type of material resists better towards high temp exposure. And also the second highlight is that, as I said previously, since we are using spirited chamber between the combustion and pyrolysis chamber, so it allows us to have a better control over the residence time and also the temperature. And the gas produced during the pyrolysis, we use it as the fuel for burner, so it results in overall higher energy efficiency. And with the bigger hopper, the feedstock, it allows the operator to be involved in a minimal way because they just need to load the feedstock once, 2 times, and then they can just let the equipment runs themselves. As for the specification, we use 3 motors, 1.1 kilowatt of the motors. These motors are used to drive 3 different augers or screw. And also we utilize a thermocouple, K-type thermocouple, to continuously monitoring the temperature of burner, temperature of a combustion chamber, pyrolysis chamber, and also the temperature of chimney. As for the feedstock, actually, our equipment is designed to be able to accommodate every type of feedstock as long as it's organic feedstock with a low moisture content. We recommend to our clients or partner to use feedstock with moisture content lower than 15%. As for the another requirements for the feedstock, if the size of the feedstock is more than 3 centimeter, for example, with the corn cobs, we need to to shred it into smaller pieces because our equipment is designed to process feedstock with particle size less than 3 centimeter. And recently, our engineering team is developing a new features that we would like to incorporate soon in our equipment. For example, our engineering team is now designing and testing the biochar bin outlet gate valve. This one is used to add more safety precautions because during the replacement of the biochar collection bin, we need to make sure that there is no syngas or pyrogas escape from the outlet of biochar. So we need this feature. And also we will use soon the slow speed motor so that by using this kind of motor, the augers can run continuously instead of intermittently. At the moment, our equipment, I mean, the augers are running intermittently. There is no issue with this mode of operation actually, but we would like to rotate or to move it continuously because it will increase the heating rates of the feedstock because the feedstock is continuously mixed by running the augers continuously. And also one more feature that we would like to incorporate in our equipment is that our engineering team is developing a new airline design. The main purpose of this feature is to mix the syngas and air or oxygen in a proper ratio so that the combustion in the burner will be more efficient and to provide a complete combustion. This one, I will explain briefly on how our equipment works. Hopefully it's clear enough for you. So it's quite simple actually. First of all, the operator need to prepare feedstock. Mainly, they need to make sure that the feedstock moisture content should be below 20%, but we always recommend to the clients to for the moisture content, it will be best if it's below 15%. And then once everything is ready, the operator will be loading the feedstock into the bigger hopper and also the fuel into the smaller hopper or burner's hopper. And then they run manually. In the first place, they run manually both augers for the feedstock and also burner in order to fill up the barrel, both feeder barrel and burner barrel with the biomass. Once it's done, then the operator will ignite the fuel in the burner manually using butane torch. And then they start the blower burner to supply enough oxygen to initiate the combustion. And then once the temperature of the burner reach stage 2, we use 500 degree, the first stage is 250 degrees Celsius. We run the equipment during this period manually, but once the temperature of the burner reach 500 degrees Celsius, the equipment will be run automatically where the operator just need to switch from manual to auto mode. During this automatic mode, the screw will be run automatically in intermittent mode. So in this step, we just need to the operator just need to monitor the process. Basically, they do not do like complicated task because the equipment is run automatically. So they just need to make sure that there is no stuck on the auger because sometimes, for example, if the feedstock contains like a foreign objects like a stone, for example, then it will cause a problem. So it's important for the operator to do regular check. And during the pyrolysis process, the biogas or syngas is produced continuously, and the syngas is then collected, channeled through a pipes, syngas pipe. We have 3 syngas pipelines. All of the pipes are going to the burner, and all the syngas from all the lines are then combusted in the burner, producing extra heat, and this the heat produced is then used for pyrolysis process. So by utilizing the syngas, it's very useful and for us to minimize the consumption of the fuel for the burner. Actually, after 1 to 2 hours of operation, most of the fuel for burner are relying on syngas instead of the biomass fuel. And then finally, after a certain period of resident time, the biomass, which is already carbonized, completely will be transferred into the collection bin. And once the bin is full, the operator needs to replace the bin with another empty bin, and so on. So that's the general brief description of how our equipment works. I think Paul, you will like to you will continue the presentation then.
Now
Paul.
now you can unmute yourself. Sorry.
Yeah, sorry, I was struggling with unmuting myself. Okay, I will quickly jump through the rest, because this was the engineering, I guess, was the most interesting part. Quickly on our emissions and biochar properties. So we benchmarked ourselves against what's required under the Global Artisan C-Sink. So in terms of emissions, we look at 2 specific emissions, CO and CH4. Contiki, typically for CO, has like between 20 to 40 grams per kilogram of biochar, and CH4 30. But our equipment emits 0.5 to 2 for CO and less than 0.1 for CH4. So that's why we say it's almost like for our corn cobs or rice husk biochar, the parameters fulfill with WBC agro, and the temperature of our system has been for agriculture. So just to like wrap up what Mohammed explained earlier, but here just to go back on how with our solution we're addressing the global artisan C-Sink challenges. So we created automated tech with minimum labor required, much larger capacity, almost no CH4 emissions, expected useful life of 5 to 7 years by using SS304, user-friendly MRV tool and process with little input required using Contiki, and it's still affordable. So our equipment is 2 to 3 times cheaper than other equipment with comparable capacity, 5 times cheaper than the ones from how we address it, how we stay competitive, a little design being manufactured in developing countries, so we can tools will limiting manufacturing. We don't see ourselves as an equipment manufacturer, but we want to drive the adoption of biochar production and application, and then offer to our clients and partners carbon credits proceed sharing, and we help with different facilitation of different financing options. I think we're at the 20-minute mark, so maybe Mohammed, you can jump to recent implementations in Asia, just to also share with you like how we're working with specific partners. So here are the examples of like a rice mill in Philippines, corn mill in Indonesia. We also started selling to biochar project developers elsewhere, but the way we work is that we put our equipment next to the corn mill or like rice mill. we participate in the development and operations of this equipment and sometimes multiple units of equipment, produce biochar from the residues like rice husks or corn cobs, and then we provide initially for free, and later on we'll start charging the farmers for biochar so that they can get the benefits, and we achieved agricultural yield improvement up to like 95% while reducing fertilizer by 50%. So some of our implementation, and just the final page. We are a company based out of Singapore, but we operate in Indonesia and Philippines primarily. Mohammed is in charge of operations and engineering. Our teams are more or less spread across Indonesia and the Philippines. Yeah, I think that would be it on our side. Please ask us any questions. And I explained a little bit on the engineering in the chat, but I'm not an engineer. So if there is anything else we could clarify, then Mohammed probably can do it better than me.
Thank you very much, Pavel and Mohammed. There was a very interesting period where you spoke very quick due to a time lag. But
Sorry.
it was nice to hear. Great presentation, very interesting. If anyone has a question, please write into the chat now. So you got one question from, no, Pavel already answered this question. One of my questions would be, so I saw you have a dry quenching process that basically only involves letting the drum cool down on its own. I'm wondering how many times this doesn't work, because from my experience, some feedstocks tend to keep glowing unless you're really good in getting the oxygen out. Do you have any issues with the dry quenching?
So far, we experience a small issue with dry quenching, but we solve already the issue. For example, from our experience, using rice husk as the feedstock for biochar production, it requires like just 24 hours of cooling down period, and then in the next day after 24 hours we can directly remove the biochar from the bean into the bag or the sack. But in case of corn cobs, it requires a longer period of cooling down. It takes like 48 to 72 hours for cooling down. The reason is because like the shape and the texture of the shredded corn cobs is more woody compared to the rice husk. So it contains heat. It keeps the heat longer for releasing the heat or for heat loss. So that's the reason why it requires like more than a night, even more than a day to cool down the biochar from corn cobs. Yeah.
My second question, just a follow-up question, was so I know CSI is also certifying reactor designs. Did you already try to get your reactor design certified?
We're days or like hopefully 1-2 weeks away from that, hopefully. So yes, so that should be from what we understand, that should be the first high-tech equipment endorsed once it's endorsed, right? It's not endorsed at the moment, but once the first one endorsed under the Global Artisan C-Sink.
Okay, great. And sorry, I have too many questions. Maybe too interesting for me. So for you manufacture this equipment yourself and then send it out, or is it manufactured under license from local engineers?
Sure. So we have in the Philippines, we have our own manufacturing facility, which we also use for the product development. In Indonesia, we're working with contract manufacturers because in Indonesia, we have our own biochar projects development as well. And in the Philippines, we're selling it to international clients.
Okay. Great. And one question from Paul Anderson. What is the biochar output per hour or per day
So here, if we use pelletized feedstock, it can process up to 100 kg of feedstock per hour. With the 40% conversion rate, we get around 40 kg. And then there's a question how long your team is going to operate it. In our own facilities in Indonesia, we currently trying to operate for 12 hours a day. So you can get up to 500, with pelletized feedstock, you can get up to 500 kg per day.
And another question from Thomas van Rossum. How is the maintenance done?
So Thomas,
Yeah.
so it's continuous. Yes, it's continuous in the sense it's not batch, but like it's continuous, right? But it doesn't mean that we operated 20 people, but we haven't tried it. It will be very intense, like, probably if you want to max it out during the normal work. And then the next morning before you start production, you clean the chambers, mesh, etc. And then you start the production again. So it has to stop from time to time, but it's a continuous versus like batch system, right? It's not a batch system.
And maybe the last question, two questions more. Do you have any tar issues in the free tar lines that you per singles lines?
Yeah, I'll try to answer the question regarding the tar issue. Yes, it produces a lot of tars actually, but these tars are deposited or accumulated only in the parts which is there is no high temperature exposure. For example, on the biochar outlet, that's where the tars are accumulated mostly there. But inside the combustion chamber and pyrolysis chamber, there is no tars because it's quite high temperature, up to 600 degrees Celsius, and the tars are just burned inside. What we are doing so far is, as Powell said, so we do like a regular or daily maintenance, but it's like the light or the easy one. But every 3 months, we need to do like an overall maintenance. So we open the combustion chamber, we clean the specific parts of the equipment where the tars are accumulated there. Until the tars are removed, actually there is no significant issue we faced so far, but we decided to do like an overall maintenance every 3 months just to make sure that the performance of the equipment will be high or optimal.
Okay, great. And there was a question by John Webster about no, by someone, what's the cost, Vera? What's the cost of the system? So Pavel, just for online visitors, so Pavel said international clients, we market it at $10,950 per unit, which to me sounds very cheap. So I guess that's also the whole point of the whole unit.